Okay, quick warm-up, classic problem about a lighthouse or anything with a shadow. So you have this lighthouse. Yeah, it's a horrible lighthouse. Casting a shadow. Okay. And it's 128 feet. And then you have a lamppost. Horrible lamppost. That measures 5 feet 3. And it's an 8-foot shadow. Right proportion can be used to determine the height of the lighthouse. Well, you just set them up the way you have them. This is your unknown. So x is to 5 foot 3, which is 63 inches, as 128 is to 8. And so now we multiply 63 times 128 is 8,064 inches divided by 8x, or equals 8x. Now we divide by 8, and we get x equals 1,008. But remember, that's inches. We don't normally measure in inches, so we divide by 12. That gives us 84 feet. So moving on to new stuff, which is really not new stuff, it's just more of the same with similar triangles. So what does similar mean? It means congruent angles and proportional sides. Those are the two properties of similarity. And the three ways are AA, SAS, and SSS. Similar. What does congruent mean? Congruent means equal, same. I don't know why I have sames. Same. So the angles are congruent and the sides are congruent. If two triangles are congruent, they're also similar. And they have a 1-to-1 ratio because they are the same thing. Okay? So, example 1, determine whether or not the triangles are similar. If so, write a similarity statement, reason why, and scale factor. So, right off the bat, we have a side, an angle, and a side. We have a side, an angle, and a side. Okay, so even though there's no numbers here, we can think about it in this way. Let's just give it a number. Let's say this is 3 and this is 7. All that matters is, since this, on the small one they're the same and the big one they're the same, it's going to be a 3-to-7 ratio. And you do have the SAS, so it is yes. The vertical angles prove it, the A, and the A is included between the S's. So we have SAS similarity. And on this one, we can say RST. I'm not having a good time writing here. Try that again. RST is congruent to, really no worry about this, XSW. And the scale factor, we don't know. It's not possible to tell it. We gave an example here, but we don't know what it is. If we had numbers, in this case, it would be 3-to-7. Example 2. Well, obviously no angles listed, so this is not going to work for AA or SAS. So we're looking at a possibility of SSS. So I'm going to rotate this so they look the same. So Q is going to be down here, P up here, that's a P, that's an R. So RP is 9, and so is RQ, and then this is 6. So now we can see that 12, 9, 12, 9, and 8, 6. So we just have to prove if 8 to 6 is is the same as 12 to 9. If it is, we're good. Now we have two choices here, remember. We can turn these into decimals. 8 divided by 6, 12 divided by 9. Or we can cross multiply. And we get 72 equals 72, which is the fact. So we have proportional sides. So are they similar? Yes. By S, similarity, we say ABC, congruent to QPR. And the scale factor is, so I just take one of those fractions and reduce it, 8 to 6, divide by 2. It's a 4 to 3 ratio, scale factor. Example 3. Again, I'm going to rotate this a little bit. It's pretty much lined up, but I'm just going to straighten it out a little bit. Here's my S, here's my T, here's my U. And ST is 10, and this is 14. So I definitely have the setup for SAS. I just have to confirm proportionality, because I do have the angle. The included angle is congruent. So I look at, and once again, if you visually see this, otherwise you can set up your word wall, small, big, and left and bottom. If that helps you. So the small left is 10, the big left is 15, the small bottom is 14, and the big bottom is 21. If I multiply these two to confirm proportionality, I get 210 equals 210. Another way is to reduce both fractions. 10 over 15 is 2/3, divided by 5, top and bottom. And 14 over 21 divided by 7, top and bottom, 2/3. So that's another way. I also could have divided 10 by 15 and got 0.6 repeating. And 14 by 21 got 0.6 repeating. 3 different ways to prove proportionality. Once we prove proportionality, then, sorry, full screen moved on me. That's fine, we'll leave it. We know they're proportional. We have SAS, similarity. And then we say STU to, I can't tell if this is over, that was a JPM. Do this. There we go. JPM. And the scale factor again is 2 to 3. Example 4. So I'm just going to take this one and rotate it a little bit. Well, that's the mirror image. Put my 90 degree here, which is S. M is out here, and here's K. K is 60 degrees, which makes this 30 degrees, which makes this 60 degrees, because we must have to 180. Notice we have angle, 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 and we have more than we need, because we have proven similarity by AA. We don't need all three. And then just pick your order. QRT, okay, and MSK, same order. And do I know the scale factor? I do not, because there are no numbers in the sides. Example 5, determine whether or not they're similar. Okay, again, I'm going to turn my triangle to kind of match. I'm going to put W up here, Y goes over here, and S goes over here. SW is 12. SY is 16, and angle S is 42 degrees. Well, I do have matching angles. I do have the setup for SAS. I just have to prove proportionality. So 18 over 24 and 12 over 16. Notice I could have also done 18 to 12 and 24 to 16. if you think about the properties of ratios we talked about, sorry about that, trying to catch that. Notice that this is my first one at the top. I go 18 to 12, 24 to 16. It's the same thing. If I cross multiply, what am I doing? 18 times 16, 24 times 12. So you have multiple ways. That goes back to the word wall that I said you can mix up the words here and here just as long as you're consistent. So it's all okay. There's not one way to do this. Get comfortable with what works for you. Now, I can multiply these and get big numbers. I can divide 18 by 24 and 12 by 16. I can also reduce, which I'm going to do right here. 18 and 24 both have a 6, 3 and 4. 12 and 16 both have a 4, 3 and 4. If I would have divided both fractions, I would have got 0.75. 16 times 18 does equal 24 times 12. And you have a calculator, so that would be easy to do also. So are they similar? You betcha. How are they similar? Well, SAS, similarity. AJK and SWY, same order. Scale factor. Now notice I went AJK, so the bigger one to the smaller one. So I'm going to say 4 to 3, not 3 to 4. Example 6. Okay, this is one of those ones where I like to so this is L, this is N, and this is M. This is L, this is Q, this is P. Now, if you don't need to do this, that's fine. I need to do this. This is 10, and this is 8. This is 15. And this is 12. And L is L, like the reflexive property. But here's the problem. It doesn't matter at all whether or not these are proportional sides. Okay? Because of the fact that what I have here is angle, side, side. We don't have that rule. We don't have ASS as a rule. So even if the numbers work out, 8, 12, 10 to 15, and they do, it's 2/3. It's a 2 to 3 ratio. But the problem is, we would need these two angles to be the same, not L. We would need the included angle. So the answer is no. Find the value of x in similar triangles. Okay. So notice, obviously, x plus 5 and x plus 1 correspond to each other. But you've got to think about the fact that this one up here, or you could turn either one of them, you got to think about it that way to line up with EBD. Okay? So that you can think about it folding over. So, in this case, the line connecting the two angles that are marked similar is 12 and 15. So, again, I can set up my proportion either way. And I can go x plus 5 to x plus 1 equals 15 to 12. But now I just have to do the math. So don't forget to distribute. So I'm going to write out distribute. You're not adding. You're not just writing without parentheses. You need to distribute. Okay, I'm going to subtract 12x and get 3x over here. I'm going to subtract 15 and get 45 over here. X is 15. Now what my instructions say to do? Just find x. It says find the value of x in the similar triangle. That's it. It did not say to find the opposing sides. If it did, then I would plug in 15 and get 16 and 20. But it was not asked to do that. Okay? That's that one. This board's acting really wonky today. I apologize. Okay, so remember, alternate interior angles. So if I flip this one, the x plus 18 and the x minus 3 correspond to each other. And if you don't need to redraw it, you just kind of can visually think of it that way, that's fine too. Now, x plus 18 is for the bigger triangle. That means the 16 goes here and the 4 goes here. Now I distribute. 4 times x plus 18 equals 16 times x minus 3. That's 4x plus 72 equals 16x minus 48. I'm going to subtract 4x and get 12x. I'm going to add 48 and get, let's see, 10, 120. Divided by 12, x is 10. Once again, it tells me just to find out. If I wanted to plug it in, I can plug it in and get the sides of 28 and 7. Okay, similar idea here. Just more practice. So I've got my two triangles, E, H, G. I have a 6 and I have x plus 5. And I have my bigger triangle, E, and D here and F here. This is 12. And this side, gotta be careful, is x plus 5 plus 9. So x plus 14. Now I set up my ratio, 6, and I can do x plus 5 here, it doesn't matter, equals, well, I keep the same structure, 12 over x plus 14. I'm just going to go right into distributing. 6 times x is 6x, plus 84, 6 times 14, equals 12x plus 60. I'm going to subtract 6x, and I'm going to subtract 60, which gives me x equals 4. Over here, I'm going to redraw my triangles. P, S, T. This is x plus 7. This is 6. This is P, this is R, this is Q. Now this is 8, but this side down here is x minus 1 plus x plus 7. So that's 2x, and 7 minus 1 is 6. So now I just set up my proportion. I'm going to write it the other way this time. I'm going to say 6 to 8, x plus 7 from the same triangle as 6, 2x plus 6. Now I just cross multiply and distribute. I'll write out this time. Six times 2 is 12x, and 6 times 6 is 36. 8x plus 56. I will subtract 8x to the left this time, which leaves me 4x. I will subtract 36, which leaves me 20, divide by 4, and x is 5. And that's it.